So now we get to sketch stuff. Sketching's always fun. They want us to sketch a reflection in the x-axis. Speaking of sketching, if you've ever taken an art class where you had to take a piece of paper and put wet ink or paint on to the paper and then fold the paper in half, squish it together, and then open it up again, and you have this perfectly symmetrical, well, mostly perfectly symmetrical picture where it's reflected on both sides. If you think about that same method, if this line were wet ink and I were to take my paper and fold it along the x-axis, when I'm reflecting something on the x-axis, then the image that I get when I do that should be the same as if I had taken that art class project and squished it together and opened it back up again. So what that looks like is I'm reflecting this on the x-axis. That means that my x stays the same and my y flips up and down. So negative becomes positive, positive becomes negative. If I start with this point, it's at -2, that's going to stay the same, and 1, so it becomes -2 and -1. This point is at 0, which stays the same, and 3, so I'm going to make it -3. This point is at 3, which stays the same, and 4, so it becomes 3 and -4. And this point at 6 and -2, so it's going to be 6 and +2. Now I can connect my dots, and I apologize for this being imperfect because that should have crossed at the same spot. Well, whatever. I apologize for it being imperfect because I don't have graph paper, but you get the idea. You can see that if I had taken this paper with this line on it, squished it, then opened it back up again, I would have this perfect reflection over the x-axis. And as you can see from the coordinate points, now the y points are all the opposite sign and the x points stay the same. So the last part of this question asks you to state the domain and range of each function. Well, we just said that x stayed the same. So the domain for this function is all the possibilities for x. So x is going to be between 6 on the big side and -2 on the little side. It stays the same. Didn't have to worry about that. The range for the original function would have been all the y values that it could have been. So it goes up to 4 and it comes down to -2. So we would have said that y is between 4 and -2. But the new range, so we call that y prime, has flipped. So you can actually just flip these values, or you can look at the graph and figure it out again. So now 2 is the big point and -4 is the low point. So y is now between -4, whoops, that's a little bit crazy, -4 and 2. So you see how the range has flipped just like the function flipped, which makes sense because it's, relative to the function.